Good morning, all of you. This is Naresh. In this class, I am going to explain about how to locate the centroid or center of gravity of an L section and T section. The position of center of gravity is very important because the stability of civil structures and automobile parts depends on center of gravity. So here you can see the diagram of an L section. The question is locate the center of gravity of the given L section. The dimensions of an L section is 20 mm thick, 100 mm base, 80 mm height. First of all, the given L section is split up into two small rectangles. That is, first one is bottom horizontal rectangle. The dimensions of bottom rectangle is base b1 equal to 100 mm and depth or height d1 equal to 20 mm, and another rectangle is vertical. The dimensions are base 2 equal to 20 mm and height or depth d2 equal to 60 mm. Okay, now I am calculating the areas. A1 is the area of a bottom rectangle, A2 is the area of a vertical rectangle. Okay, area A1 equal to base B1 into D1 equal to 100 by 20 equal to 2000 mm square, and second rectangle A2 equal to B2 into D2, that is 20 by 60 equal to 1200 mm square. Now I am considering the reference axis. The centroid of a body is calculated with a assumed reference. There is no set rule for selection of axis of reference, but in general practice the axis reference is the bottommost line of the figure for calculating the y bar, and edge left edge line of the figure for calculating the x bar. Because of this practice, the entire figure lies in first quadrant, and the values of x and y distances become positive. Now I am drawing the diagonal lines for locating the individual centroids. Okay, C1 is the centroid of a bottom rectangle. It is at a distance of x1 from y axis, and y1 at a distance of y1 equal to d1 by 2 from x axis. Similar way, C2 is the centroid of a vertical rectangle at a distance of x2 from y axis and at a distance of y2 from x axis. Okay, x1 equal to half of the base. uh, the center of gravity of a parallelogram or rectangle is at a point where its diagonals meet each other. So x1 equal to b1 by 2 and y1 equal to d1 by 2. Similar way, x2 equal to base 2 by 2 and y2 equal to d1 plus d2 by 2. All these values are written in tabular form in the next slide. Here xc is the distance of center of gravity or centroid from y axis, and yc is the distance of centroid or center of gravity from x axis. From basic expression, x equal to a1 x1 plus a2 x2 by a1 plus a2. Therefore xc equal to 35 mm. Similar way, yc equal to a1 y1 plus a2 y2 by a1 plus a2, and the answer is yc equal to 25 mm. So this is the final answer. So where xc and yc are the centroid points. Now I am showing the final position of the center of gravity. Here C1 and C2 are the individual centroids, where CZ is the centroid or center of gravity of an entire section at a distance of xc from y-axis and yc from x-axis. Now coming to the next problem, that is a T section. It is a inverted T section. It is the reverse shape. It is the reverse shape of T section. So the dimensions are given here. Locate the center of gravity of the given T section. Question. Similar way, the given section is split up into two small rectangles. That is, first one is bottom rectangle. The dimensions are b1 equal to 100 mm and d1 equal to 20 mm. And second one is vertical rectangle. The dimensions are b2 equal to 20 mm and d2 equal to 60 mm. Sorry, uh, the total height of the given T section is 80 mm. Now A1 and A2 are the areas of individual rectangles. A1 equal to area of the bottom rectangle, that is A1 equal to B1 into D1, that is 2000 mm square, and A2 equal to B2 into D2, that is 1200 mm square. Now I am considering the reference axis, that is bottom edge line is x-axis and left side corner edge is y-axis. Now I am drawing the diagonals to locate the individual centroids, where C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis and y1 from x-axis. Similar way, C2 is the centroid of a upper rectangle at a distance of x2 from y-axis and y2 from x-axis. Here x1 equal to b1 by 2. X1 equal to half of the base. So x1 equal to 50. Next y1 equal to half of the depth. That is y1 equal to 10 mm. and similar way x2 equal to half of the base of bottom rectangle. Here x2 equal to x1, and y2 equal to d1 plus d2 by 2, height of the bottom rectangle plus half of the upper rectangle. All these values are written in tabular form. Here xc is the distance of center of gravity from y-axis, yc is the distance of center of gravity from x-axis, x equal to a1 x1 plus a2 x2 plus a2 x2 by a1 plus a2. Answer is x equal to 50. So therefore the distance of centroid from y-axis is 50 mm, and yc equal to a1 y1 plus a2 y2 by a1 plus a2. Answer is yc equal to 25 mm. The final location of the centroid is here also c1 c2. Here also c1 c2 are the individual centroids, and cz is the centroid of an entire section. cz is at a distance of xc from y-axis and yc from x-axis. You can also solve this T section problem by using symmetric condition like this. Now I am taking same problem. Here you can observe it. Here I am taking y-axis at mid part, that is symmetric about y-axis. The given figure is symmetric about y-axis. So therefore the centroid lies on symmetric y-axis only. The values of x are 0 because it is symmetric about y-axis. Therefore c1 c2 same. Next y1 and y2. y1 equal to half of the height, y2 equal to d1 plus d2 by 2, same. But the main difference is the values of x are 0 because of I am taking a symmetric axis here. So by using symmetric condition, here x equal to 0, y equal to 25 mm. The final location of the centroid is not change. So this is the final answer. In the next class I will explain about how to locate the centroid for I sections. Okay, thank you.